Okay, seniors.
All right, seniors, let's get started. She said all right this time.
By get started, that means we're quiet and looking at the board.
Okay, so today we're moving on to level 3, applications of higher order derivatives. All right. On a level 3, we're going to have to do a couple more things. So you need to make sure that you're paying attention to the difference between level 2 and level 3. I'll tell you what a level 3 is required in a minute, but let's take some notes on vocabulary. Let me turn this on. There we go. Okay. Oh, no. Ms. Stevenson, do we have one for him? Okay. I thought I made them too. I'm sorry. Vertical motion. Sure. Yeah, you can. Gentlemen.
Oh, it's in the same.
PowerPoint.
Same PowerPoint as.
Yeah, but I added to it. It wasn't on there. Okay. Vertical motion. We're going to use two formulas. Vertical motion is the formula. Man, I cannot talk or write today. Used to calculate the height, time, distance, and velocity of an object. Thank you, Ms. Stevenson. For this week, we will only be doing literal vertical motion in an upwards fashion. When we come back from break, we'll be talking about downwards vertical. Like if you're standing and like you throw a paper airplane. Yeah. Okay.
Oh, like actually throw it.
No. The formulas you will use. Formulas. We're going to have two formulas. The first formula, f of x, is equal to negative 16x squared plus vx plus c. I'll explain to you what those parts are. What did you say? This is not made up. This is an actual formula that is used in physics consistently. Okay. This is used when we have the distance in imperial measurement, meaning like feet, inches, not metric. This one will be used when we have the metric. So if we use centimeters, millimeters, meters, kilometers, for the time being, we will be giving you which formula to use, but know that eventually we will not be. We will put these formulas on the formula sheet. I'll print out new ones, but you will need to determine which of the two you will use. Okay? For the time being, you are just given one of the two formulas. Okay? Thank you, Ms. Stevenson. Now, I'm sure you're wondering, what do all of these variables mean in context? C is the initial height. Of the object. C is the initial height of the object. You got him? Okay. Meaning that if I am standing on a cliff and I decide to throw a ball off the cliff, my height is going to be where it releases from my hand, not the ground, because I'm not on the ground. Okay? Even if you are on the ground and you throw a ball, the ball is not on the ground. Right. It's somewhere, it has some initial height. That's what C stands for. Okay? What do you say? Yeah, the starting point. X is going to be the time. Remember, it all depends on the problem. I can't give you the exact time or the exact measurement of time. Usually it's seconds, but just in case, it might not always. Is it the fan sound still?
In here?
Yeah.
That whistling? I think so.
Yeah. V is the initial velocity. V is the initial velocity. So the velocity that it has when it leaves your hand or foot or whatever else. And then f of x. Julie? No? Ava? F of x is the distance or height of the object. So all of these things will be used to create the equation, which is the first part of level 3, is creating the equation. Ready? Is anybody still writing? Louis, you good? I can't see. Yahadi, you good? Okay. All right. So for level 3, give me a second. For level 3, you're going to have to find a few more things. So in addition to the equation, creating or finding the equation, as of now, we're going to be giving you your initial velocity and initial height, but eventually in quarter 4, you're going to be solving for all those things. Okay? Eventually, you'll solve for all those things. But for now, for the time being, we'll give you that information to create it. What else you're going to find is you're going to find the time, so in seconds, minutes, whatever time is measured in, to reach the maximum height. may need to add some things or move some things around for that, okay? I know some of you are still writing, but I'm gonna draw a picture of what it means. Okay, so here's what the graph of an example would look like. So if I'm throwing a ball in the air, the maximum height will be here. When it reaches its maximum height, what do we know about it? What do we know about the speed?
So is that at the very top of the point, is its greatest velocity and as it falls down?
Not the greatest velocity. I mean, okay, so yes, no, it's not the greatest velocity, it's the greatest height.
No, it's flying. Oh, yeah, like that. Whose velocity is how fast it got?
Right, so when it's at that maximum point, what is the velocity? 0. Good. When it's at that maximum height, the velocity is 0.
What does that mean that the velocity is 0?
It starts.
Well,
Not yet, before it starts decreasing, it gets to its maximum height, and then what? The velocity is 0. What does that mean when velocity is 0? It's not moving. So it stops, it's like, what did they say this first period? What did they call
Rest.
it? Rest. So if they're just really quick, this is the motion
yeah.
of the ball. If this, we were talking about the velocity would go up, okay. Okay. The velocity would be going up and then it plateaus or it rests because it's waiting, it stops, it's at its maximum velocity. This is 0 and now it's decreasing. So that's what this means. Does that make sense? It's important that we understand that when the velocity is 0, our item isn't moving because it's going to help us check to make sure if some of our numbers are correct.
So even if it stops for like a millisecond, it's not moving at that maximum height. Okay? Sorry, I lost my train of thought. So, the velocity is 0. So we're going to have to figure out that, and this is where we're going to use algebra instead of the calculator. But how do I find the velocity function? What is the velocity function?
Look on the board
What?
or your notes.
What'd you say?
V prime prime.
Oh, no, so close. That's acceleration, but it's not V.
S.
Not ST.
That's this price.
S prime of t. This is the derivative of your displacement function or your position function. This is the first derivative.
Speed.
No,
Right.
nope. We don't call this speed.
Wait a minute. Velocity. Speed.
Velocity is speed, but this is not speed.
What's that speed?
It's just called the displacement function or the position function. I don't know why they use S. Don't ask me.
It has to be speed, it has to be speed.
It's not speed.
What is it, SpongeBob? I don't know.
Probably.
This is calculus. So the language that we use for this particular content is different. Calculus and physics, we say velocity. If you need to relate it to speed to make it make sense in your brain, sure. But when you put that on your assessment, you need to make sure you're using velocity because that is the language that we're speaking. You ever heard the saying, when in Rome?
No.
This is, well, get some culture, because when in Rome, you do as the Romans. This is calculus, we gonna speak like we in calculus.
So the S function is not speed, okay? It's position. The next thing you're gonna need to do is find the maximum height. Find the maximum height. You're going to use your answer in part B, you'll see in our example, to find the height. A lot of students will plug it in or substitute it into the velocity function. You cannot do that. You need to substitute it into the original function. You'll see what I mean when we do our example, okay? Elvis? What'd you say?
So that's position slash distance?
Yes, because there's no prime,
Okay.
okay?
And if there's a prime, it's,
Velocity. So if it is a prime, it's velocity. Double prime is what?
I thought S prime was displacement.
No, no, no. Displacement and position is this one.
Oh,
It's also on the board,
Dis-
written in green.
Did I give that to you yesterday?
Yes, because you wrote it down, because I got that.
Displacement and position. This is velocity, which is the derivative of displacement. Okay? What's the double derivative from yesterday?
It's on the board.
AFT, what's AFT stand for?
acceleration.
Acceleration. And then the last thing you're going to need is to find the time it takes to hit the ground. Yep. When it reaches the ground, what's the height?
0.
0. Very good. Height is 0. That means you're going to need to set your displacement function or your position function equal to 0. And this is when we'll use the calculator, like we did yesterday, okay? When you're done writing that down, take out the example that I passed out. Did I pass it out or did you pass it out? You all did. Okay. Emily, I'll pass this to you in a minute, okay? And Aislinn.
Oh, does somebody come in later? I got Aislinn one.
Emily. Oops, sorry. Emily, can you pass that to Emily? Danielle, Emily. Okay. We ready? Louis?
Maybe I will.
So as a quick recap, guys, before we get into our example. People are talking while we're talking, that's a problem. Recap is on the left-hand side of the board. S of T is displacement position. It's your original function. S prime is your what? It's written on the board in purple.
Acceleration change of velocity.
S prime is what? Velocity. And then S double prime is what?
Acceleration.
Mm-hmm.
Acceleration. It's important we know the difference between those.
And remember to use the right notation because, yes, I know that S double prime is acceleration, but I'm not asking you to write S double prime. I'm asking you for the acceleration function. So remember that tomorrow on your assessment. Okay? All right. Let's look at the example. We should have this all. Does anybody need an example? Do we all have one? Okay, no response. So I'm going to assume everybody has one. It says an object is thrown vertically upward from a point 15 meters above the ground at an initial velocity of 49 meters per second. Use the formula S of t equals to negative 4.9 t squared plus v of t, or vt, plus c, to answer the questions below. All right, so we need to create an equation. If we're reading our problem correctly, which we should be, we can see that the initial velocity is 49, so that is going to be v in my equation. Are there any questions on how I got that?
We put it in conditions.
Yes, we're going to put that where v is. Additionally, it is thrown from a point 15 meters above the ground. So this is C. This is my initial value. This is my starting point, 15 meters above the ground. So I'm going to substitute it in for C. So your function is S of t equals to negative 4.9 t squared plus 49 thanks, plus 15. So you see, we gave you the formula to use. You just have to substitute in the correct values, which are given to you for now. The correct values are given to you for now. Yes. Uh-oh is right. Okay. Questions? Good? Okay. So, part B asks, how many seconds does it take for the object to reach its maximum height? So we are looking, oops, sorry. Oh, my pen's not working. Great. So if we threw it, we are looking for this point right here. So according to the notes that I gave you, what do I need to find?
It's stuff.
Yeah, but what do I need to find? I gave you what you need to find.
Look for the list that we just wrote.
In 3. Yeah, velocity. So we need to find velocity. How do I find velocity? How do I find velocity?
S prime t. So
S prime.
pull out the prime from that equation.
Pull out the prime?
I mean, make it
Yeah.
How do I find the prime? What does prime mean?
4.9 times 2 plus 49 by something.
Yeah. However, you're forgetting something.
No, the negative.
Negative.
I see that.
Yeah, so we're using what rule though, Dario? What is that called?
Power?
Power rule. We're using the power rule.
Do we hear that on the other side of the room?
Yeah, I heard this. Power.
Power rule. Yeah. As of now, we are only going to be using power rule. When we come back from break, when we move on to this, we will be using other functions for level 3 and level 4. Okay?
EX.
Yep. Yep. Because real world data doesn't follow the same pattern. They're all different. Okay. So now that I found the derivative, I'm not done because I need to figure out time. And remember, when it meets its maximum height, excuse me, when it reaches its maximum height, the velocity is 0. So I'm going to set this equal to 0 and solve for t. This is just algebra. You don't need the you need the calculator to solve for t, but you don't need that app that we used yesterday. So I'm just going to use algebra. I'm going to add 9.8 on both sides, because I don't want a negative coefficient. So that gives me 9.8. I know. I have sent emails about that. How do I solve for t here? How do I solve for t?
Divided by 9.
Very good. 9.8. 9.8. T is equal to 5 seconds. And I realized that I did not give us enough room here, so.
We gotta do our statements.
Yep.
Write small in your papers.
So you would say after 5 seconds, the object reaches its maximum height. I can't spell. Wretches. Sorry. I'm writing like you guys now, just all over the paper.
What is the maximum height it reaches? Now we gotta find the height.
Or you can say it reaches its maximum height at 5 seconds. Anything similar. It doesn't have to be exactly this, as long as it answers the question. Okay?
Hey, those looks really good.
Yeah, we did this almost exactly like this in November when we were doing instantaneous rate of change. Yeah,
No.
yeah,
We also said this yesterday.
yes.
Went over this.
So, yeah.
Seniors. Part C asked me to find the maximum height it reaches. A lot of students, like I said, will try to substitute in the 5 into the velocity formula. This is why it's important, Dariel, to actually label it so we know, okay? Velocity does not give me distance, so I cannot use this formula. I need to go back to the original equation because it gives me height, okay? It gives me a distance. This does not. This gives me speed.
Got it.
So I need to substitute in the 5 for all the t's. Can somebody, well, here, what is it? Okay.
Is that S5?
Yeah.
Yeah, this is S5.
So that's similar.
Ooh, that's a big one.
You sure? Okay. So you would say the maximum height of the object is 135, nope, 37.5 meters. Do not forget the units. You will not get full credit. Don't forget the units. You won't get full credit. Questions? What'd you say? Okay. Part D asks, how long does it take to hit the ground? So we're looking for time. Again, we cannot use the velocity formula because the velocity formula gives us the speed. We're looking for something that has to do with distance. So we have to use our original formula. But when it hits the ground, what's the height? 0. So we need to set the original function equal to 0 to solve. And this is when you will use the calculator. All right. Somebody, when you're done writing that down, take out your calculator. You should all be taking out your calculator when you're done writing it down. Huh? Yeah, go. Okay. Somebody tell me what I need to do.
Hit apps.
Hit apps. Oops, not sign.
Click number 9.
Apps. Hold on. Let's slow down.
So if you were absent yesterday, please make sure that you're following along because we will not help you do this on the test tomorrow.
Yeah.
It is important that you know what buttons to press and what goes after what. So do
You did
not
this
just
yesterday.
watch, follow along on your calculator.
Remember, it's in the video too. Okay. Okay. After we hit the apps button, what do we push?
Number 9.
9.
And then we click number 1.
And then 1.
And then we click next. which
Okay.
we get track.
Why would it be okay for me to just put next?
Our highest exponent is 2.
Very good. Our highest exponent is 2. Okay? If it was changed, if it was 3, make sure you change it in your calculator. Okay, so now we're gonna push.
Graph.
Okay,
And then from there, you start plugging in the numbers, which is negative 4.9.
negative 4.9.
Click enter.
Enter.
And now you're gonna put plus sign.
Now, he's going through the steps that are on the skinnier calculator. If you have the bigger calculator, it's a list.
That's it?
Huh?
That's it?
Yeah. No.
This is valid.
Then you used a minus sign instead of a negative sign. Go ahead. 49 and 15. Now what?
Click graph.
Okay, good. All right, let's look at the numbers. Can we have negative time?
Monday? No, we can't.
We can't have negative time. So this makes no
It
sense.
penetrated the floor.
No. You just can't go backwards in time. Time is forwards.
I thought it was this.
No. No, that's a good question or a good comment. Dario thought this was distance. This is not distance. This is actual time. Okay? This is
Hold
time.
on.
Yeah.
Yeah.
Okay? What'd you say?
Oh, that's 15.
Okay. So, T is equal to 10.3 seconds. Round to the 10th or 100th place. Either one is fine. Okay? 10th or 100th. Yeah, go. Would you get full credit for this answer? No. Why?
Put it in words.
Words. What'd you say? You said notation?
I just wanted to put it in words.
So you would say the object hits the ground. No, you should not get a negative. You did something wrong.
Yeah, I know.
Well,
At 10.3 seconds.
probably put a minus sign.
No, you just this one.
If you were not here yesterday, the video from yesterday is up and it tells you how to do this. I'm going to in a minute. Hey, Dario, give me a second. I'm going to in a minute post the names of the apps on the calculator, or on the phone, so you can download it. Okay. I don't know if it's free or not. Somebody just told me what it's called. No. Why are you laughing? That's not funny. Okay. On the back, you have one problem to do, and you need to show it to me before you leave so that you can get credit. If you don't show me, it's a behavior log. Got it? Can't hear? Oh, I'm sorry. We're skipping the last one because I realized that is a higher level skill that we haven't learned yet.